All right, let's take a look at our lesson on even and odd functions. So let's look at the algebraic way to determine an even or odd function. So if we are looking at specifically even functions, a function is even if when I replace the x's with negative x's, I get the exact same thing I started with. Okay, that's what this is saying, is if f of negative x, that result is the same thing as f of x, then this is an even function. So these are the algebraic techniques. Okay, now let's look at odd. If f is odd, then if I replace all the x's with a negative x, I'm going to get exactly the opposite of what I started with. And so that would determine if it is an odd function, if the function is odd. And you're thinking, well, goodness, everything must be even or odd. And that's not the case. Sometimes you would get functions that are neither. They're neither even nor odd. We'll talk about those as we go through this process. So let's look graphically. So let's look at the graphs of these. An even function is symmetric with respect to the y-axis. Look how each point, the corresponding point on the other side, see they're exactly, it shows you, maybe you remember these little marks from geometry, that shows that these are equivalent segments, remember that? So these are equidistant from the y-axis. They're evenly spaced, so they're symmetric with respect to the y-axis. That's what an even function looks like when it's graphed. Well then, what would an odd function look like when it's graphed? Well, an odd function is going to be symmetric with respect to the origin. So for example, if I'm looking at this point right here, that would take me certain spaces up and over to get here. Again, with respect to the origin, to get to the corresponding point, we would go down. See how we went up here and right? Here we would go down and left to get to that corresponding point. So they're symmetric with respect to the origin. And that's what a graph of an odd function would look like. Now, what would the graph of neither? Oh, there's lots of graphs of neither. I'm just going to give you one example. What if you had, something look like this? Okay, I'm going to make it even worse. What if it looked like that? So more obvious. So we see that it's not symmetric around the y-axis, and the points are not symmetric to the origin. So this would be a graphical example of one that was a function that's neither even nor odd. All right, so that's the overview. Now let's work on a few problems. We're going to first determine algebraically if the function is even, odd, or neither. And then we can use our calculator to verify graphically that our answer to part A is accurate. Then we will state our domain and range of the function using interval notation. All right, so let's do the algebraic part first. So what we're going to do is we know what f of x is. Let's find f of negative x. So that means I'm going to replace every x with a negative x, and then I'm going to simplify. So let's say negative x times negative x times negative x would be a negative x cubed. A negative times a negative is a positive. So let's see what we come up with. So is this function, so we're comparing our original to our new one, are they exactly the same? Well, they're not exactly the same. Okay, so it's not even. Are they exactly opposite? Let's see, this first term was positive, this is negative, this second term is negative, that's positive. Yes, they are exactly opposite. So therefore, this is odd. Okay, so it's odd. All right, so then let's take a look at our calculator. All right, so we have our calculator pulled up. Let's go ahead and add graphs. Okay, so let's take a look what this graph looks like. So that's 2x cubed, and then it's minus x. Now we said this was going to be odd. Oops. Minus. Okay, come. Okay, minus x. All right. Okay, so now this is, if you can see, it is symmetric with respect to the origin. See how it's perfectly spaced where this piece is up and this, let's see if we can get in. Get in a little bit, move that out of the way. So it's exactly perfectly spaced. So we can see from the graph that yes, we did a good job. We got that algebraically that it was odd. Now let's look at our next one. Oh, excuse me, domain and range. So domain, we can see by the graph, I mean we're looking at it. See the domain, everything, negative infinity to infinity, range, same. So let's write it in interval notation. Negative infinity to infinity, and the range is negative infinity to infinity. Okay, so let's look at our second example. We're going to determine algebraically, so we've got the g function. Now let's do g of negative x. Okay, so 1, and let's stick in a negative x there. So g of negative x would be the square root of 1 minus, let's see, negative x times negative x is positive x squared. And we're comparing, remember we're comparing this one to this one, and they are exactly the same. So these are exactly the same. So therefore this one is even. All right, so let's go to our grapher and let's investigate that. Okay. Graphs, okay. All right, so now we want to do square root of 1 minus x squared. Let's take a look at this one. Oh, look at there. Sure is. That is perfectly symmetrical to the y-axis. And let's look, while we're here, let's look at domain and range. So our x values go from negative 1 to 1, and our y values go from 0 to 1. Interesting. Okay, so for this one, our domain is negative 1 to 1, and our range is 0 to 1. Didn't that look like a half circle to you? Well, this makes a half circle. It's kind of fun. All right, so last one, we're going to do b of negative x. So I'm replacing the x with a negative x. So b of negative x would be what? Negative x over negative x cubed minus 1. Okay, now we're comparing, and they're not, so we're comparing the original to our function of negative x. They're not exactly the same, and they're not exactly different. exactly opposite. So this was a positive x, now it's a negative x. That's okay. This was positive x cubed, now it's negative x cubed. But look at this. This is a minus 1, and this is still a minus 1. That kind of ruins everything. So this is neither. This is neither. And so let's take a look at our graph. Who knows if I can get back up there. We'll try it. Okay, great. So let's see, let's make this a fraction. So we've got x over x cubed minus 1. Let's see what this little guy looks like. Oh, okay. So yeah, we can see that is not symmetrical to the y-axis, and it's not symmetrical to the origin. It looks like our x values are everything except 1, and our y values are everything. Okay, cool. So our domain is negative infinity to infinity, and our range, oops, no, it was everything but 1, wasn't it? So our domain was negative infinity to 1, and 1 to infinity, and our range was everything. All right, very good.